I wrote a recent newsletter about the natural history of clay, and I was so fascinated by this topic that I wanted to make a little video to explore it a little bit further with you. So here we have Earth, and as far as we know, planet Earth is unique in the universe for hosting life. Yet when you look at this spinning globe, what you're seeing is a thin layer of water and life covering what is essentially one big rock. And because Earth is one big rock, people have long wondered how life started on Earth. And for a long time, people thought that life started in some sort of primordial soup of elements, but that thinking is now shifting to a new and surprising way that life may have started. To better understand this riddle, it helps to look at what happens when rocks break down. So when solid rock begins to weather and break down into smaller and smaller pieces, it produces three kinds of particles that we call sand, silt, and clay. Sand grains are the largest particles. They are easily visible to the naked eye, and you can feel their grittiness when you rub them between your fingers. Silts are much, much smaller and feel smooth or flour-like to the touch, though you can still see individual particles. And clays are incredibly small and have unique moldable or slippery properties. So although all these three types can be classified according to size, they differ in more significant ways than size alone. So sand and silt are inert materials. In other words, they're simply broken pieces of rock that don't react to the environment around them. But clay is an entirely different entity. First of all, clay particles are so small that 1 million clay particles can fit inside of a single grain of sand. And this matters because clay particles have extremely high levels of chemical and energetic reactions with the environment around them. And tiny particles also have significantly more surface area than a larger particle would. So how much surface area? Well, a unit of clay the size of a sugar cube has as much surface area as a football field, and that entire area is buzzing with energy and interaction. The most important thing to keep in mind is that clay particles are negatively charged, which means they attract positively charged elements in the surrounding environment. So let's do a brief deeper dive into what's going on here. The primary building blocks of clay are hydroxyl ions, which consist of one hydrogen atom and one oxygen atom. And these negatively charged ions then attract positively charged elements like silicon, magnesium, or aluminum that bond into four-sided and eight-sided structures called tetrahedrons and octahedrons. These structures then organize themselves into sheets that stack in different ratios to create different types of clays with different properties. So there are about 30 types of so-called pure clays in the world, but just countless ways that these different clays can mix together in different variations. So in some cases, these sheets stack tightly together, but in many other cases, these sheets are loosely stacked with spaces between layers, and these spaces readily attract even more positively charged elements, and they can attract water molecules. And when they do that, the sheets become lubricated and slide past each other, which gives us that characteristic slippery feel of wet clay. And again, every surface of these sheets, these layers, and these particles have negative charges that attract positively charged elements, which then can attract a cloud of even more negatively and positively charged elements. And when we talk about positively and negatively charged elements in the soil, this includes everything from mineral elements to bits of organic matter, which means that every clay surface becomes a community of life supercharged with chemical and electrostatic messages. And one factor to keep in mind is that clay is incredibly important because of its readiness to engage in something called isomorphic substitution. This refers to clay's ability to swap out one positively charged element and swap in another positively charged element without losing its framework. And this matters in soil ecology because it means that clays hold onto and release much needed nutrients that otherwise wash away every time it rains. And clay is so efficient at this service that adding even a small amount of clay can alter the properties of all the soil in a given region. So given that clay has so many unique properties, it makes sense that scientists are beginning to think of clay in an entirely new light. And this is where the story of clay takes a fascinating turn. So because clay attracts charged elements, it has the ability to bond with freely available amino and nucleic acids, which are the building blocks of life. And a growing number of scientists now suspect that life on Earth started because these first proteins and genes were assembled by clays. The idea that clay could have created life is hard to grasp. So think of it this way. Proteins and genes are basically sequences of amino and nucleic acids, and electrically charged clay particles are a template for lining up and organizing these acids into coherent patterns. It's now thought that these original amino acid sequences may have started out as a minor byproduct of clay formation, but that over time, some of these sequences actually helped clay particles persist in the environment. And eventually, the amino acid sequences then became the dominant factor, and the clay elements were dropped as early proteins and genes began to form. There's so much more to the story of clay, and I'll cover this in future videos, but for now, it's amazing enough to simply acknowledge there's much more to clay than you might have realized. Stay tuned for more.